2015 has come and gone, and we still don't have self-lacing shoes, flying cars, or instant pizza. We may not have most of the technology promised to us by Back to the Future, but there is one crucial innovation we're going to teach you how to create: time travel. This is Epic How To. Now, first things first, you have to understand the nature of all existence. Should be easy, right? The key component to understand is the space-time continuum, which is basically the idea that you can't have space without time, and they are one and the same. When you affect space, you also affect time. If we experience the universe's three dimensions, length, width, and height, we also experience the fourth dimension, time. Though currently, we can only travel one way at one speed along that dimension. Stick with me. Essentially, we are all traveling through time at a rate of 1 minute per minute, which is just as boring as it sounds. Now, we're going to need to learn some science before tackling time travel, so let's begin by talking about the theory of relativity. Imagine, if you will, you are riding in a car going 50 miles per hour. If you throw a ball forward, it will appear to you to be going about 10 miles per hour forward, but will be moving forward at 60 miles per hour to someone standing on the side of the road. Let's call him Trent. If you throw the ball behind you, it will again appear to be moving away from you at 10 miles per hour, but will be moving forward at 40 miles per hour to Trent standing on the road. But here's where the universe gets tricky. Back in the 1800s, scientists assumed this applied to everything in the universe, even the fastest thing in the universe, which is... Anyone? Anyone? Yeah, you, Billy. No, idiot. It's light. But what they found was that light traveled at the same speed, about 300,000 meters per second, no matter how fast the light source or the observer was moving. The speed of light is constant. That's where a young physicist named Albert Einstein comes in. You may have heard of him. Now everyone agrees that speed is determined by dividing the distance traveled by an object by the time the object took to get there. That's why the speed of the ball appears different to each observer. You're observing two different distances for the ball to travel in the same amount of time. But if instead of a ball you turn on a flashlight, the light appears to move the same speed to you and to the observer on the side of the road. But we know the distance being observed changes, so if the speed is constant and the distance changes, then time must change with it. Moving through space changes the passage of time, making it appear to move slower for the object moving. Now, to boil all that down, the faster you go, the closer you get to the speed of light, time begins to slow down. If you travel at speeds up to 99% the speed of light, 1 hour for you will be 7 hours for everyone else. Increase that to 99.99% the speed of light, and then that 1 hour of you becomes almost 3 days for the rest of the world. Now, what's that mean for you? It means that traveling through time is entirely possible and in fact happens every day. What the hell? Said Trent, who's still back there on the side of the road. High speeds create time dilations, so astronauts aboard the International Space Station have experienced this for themselves. They hurtle around the Earth at 4.76 miles per second. Granted, that's only a fraction of the speed of light, so traveling at that speed for a year, the astronauts have only gone 0.01 seconds into the future, but still, it's a start. All you have to do is figure out how to go faster. But the bigger problem is that traveling into the future is a one-way ticket. According to Einstein, there's no way to get back to the past. So your next step is figuring out a way around special relativity. Now, I know what you're saying. Joe, why don't I just go faster than light? It's that simple. Shut up, Trent! We just don't plain know what going faster than light will do to you. Will it make you go backwards in time? I don't know, maybe. Could you also blow up in a massive antimatter explosion that destroys the whole universe? Yeah, probably. So don't do it, Trent! Dick! Chances are it's impossible anyways, so you're gonna have to figure out a way around the rules. First, let us recommend the Alcubierre drive. It's at the forefront of faster than light travel and it attempts to bend the rules instead of breaking them. Miguel Alcubierre released a paper in 1994 explaining how the drive works. It creates a bubble in space-time around the spaceship where the universe remains more or less the same. Then, it constricts space in front of the bubble and expands space behind the bubble, propelling the ship forward. Because the forces are occurring in empty space and not matter, it isn't tied to the same limitations to speed, as the ship is moving at a much slower speed inside the bubble, where all physical laws are normal. So, the bubble could, in theory, move several times the speed of light. However, the very workaround to beating the speed of light means that the spaceship wouldn't experience the time dilation one would normally feel as they get closer to the speed of light. So many theorists believe this only solves the problem of traveling great distances quickly, not going back in time. For that, you need a wormhole. Or, if you want to get more specific, call it an Einstein-Rosen bridge. As we mentioned before, we know that space and time are completely connected. And with enough gravitational force, space-time will bend. It's entirely possible that with enough force present, space could fold over on itself, just like folding a blanket. An Einstein-Rosen bridge is the theoretical path between two spots in space-time that have been folded together to touch. Now, here's where it gets really difficult, because it was all easy before I said those words. You would have to move one end of the wormhole through space-time to another location close to the speed of light, then reverse it and bring it back to the original position. If you've gone fast enough, then time slowed down for one end of the wormhole. So moving through it won't just mean you go back to the original location, but potentially to the original time as well. Did you get it? Me neither. Shut up, Trent. Again, some drawbacks. You can only go back into time to the point that the wormhole was created, and no further. So creating one of these today wouldn't mean we get to go back to check out those kick-ass dinosaurs, just that future time travelers could meet us. And we're pretty kick-ass, so where are they? Alright, look at that, you can time travel and stuff. And that's it for this episode. Of course, I already know what you're going to write down in the comments, as I have seen the future. But you should probably still write it in the comments, because if you don't, there might be a time paradox, and that's you don't want that. We'll probably cover it next in another Epic How-To. So stay tuned. I'm Joe Beretta. This is Epic How-To. Bye! Let us know what topic you guys think we should break down next in the comments below, and don't forget to subscribe.